Welcome back, everyone. Today, we're diving into a genuinely massive shift in the world of global aerospace. We're talking about India's entry into the hypersonic arms race with a highly ambitious program called Project Dhwani. Now, if you truck military aerospace, you already know hypersonic tech isn't just a minor upgrade, right? It's literally a fundamental rewriting of the rules of engagement. So we're going to break down the science, the hardware, and the geopolitical ripples this is creating, all based on the latest defense reports. Let's get right into it.
Okay, let's dive into our roadmap for this explainer. We'll start with the hypersonic arms race, decode the physics of hypersonic flight, get an inside look at Project Dhwani, unpack the scramjet breakthrough, and finally look at how this redefines regional deterrence.
Section 1. The hypersonic arms race and entering the 10,000-kilometer club.
10,000 kilometers. Think about that number for a second. That is the staggering potential strike range for the most advanced version of Project Dhwani. Just to put that massive leap into perspective, India's older conventional Agni-5 ballistic missile maxes out at around 5,500 kilometers. We were talking about nearly doubling that reach. This isn't some small incremental tweak. It's an intercontinental capability that completely redraws the strategic map.
And because of that leap, India is suddenly stepping into a very, very exclusive club. Historically, the list of nations with advanced maneuverable hypersonic tech has been incredibly small. It's basically been dominated by the US, Russia, with systems like their Avangard, and China's DFZF. But now, building on its earlier test vehicles, India has firmly secured its seat at the table with Project Dhwani.
Section 2. Decoding Hypersonic Flight, the Science of Speed.
Let's lay down a quick foundation here. At its core, Project Dhwani is a hypersonic glide vehicle, or HGV. This is a highly maneuverable weapon. It actually uses a standard rocket booster, just like a regular ballistic missile, to get kicked way up into the high atmosphere, roughly 40 to 100 kilometers up. But here's the catch. Instead of continuing out into space, it separates and starts gliding back toward its target at unpredictable speeds topping Mach 5. That's over 6,000 kilometers per hour. But honestly, speed is only half the story. And this brilliantly illustrates the real advantage. See, traditional ballistic missiles follow a predictable parabolic arc. Radars can track them the second they launch. It's kind of like throwing a rock. You can calculate exactly where it's going to land, which lets defense systems intercept it. But in HGV, it maneuvers unpredictably. It's way more like throwing a skipping stone that suddenly turns into an airplane mid-flight. It glides low, it turns on a dime, and it completely bypasses standard radar tracking and defense shields like THAAD or the Patriot system. Now, moving that fast inside the Earth's atmosphere creates an incredibly violent physical environment. The friction from gliding at Mach 5 or 6 generates absolutely immense heat. To survive that, you need incredibly advanced heat-resistant ceramics and ablative coatings. Actually, these vehicles run so hot that space-based sensors basically rely on their intense infrared signatures just to track them. It's this wild, delicate balance of extreme physics and advanced metallurgy.
Section 3. Inside Project Dhwani. Specs, Speed, and Timelines.
Fittingly enough, the name Dhwani actually translates to sound in Sanskrit, which is a great nod to the sonic barriers this tech shatters. Now, what's really interesting about this data is that Project Dhwani isn't just one single missile. According to defense reports, it uses a wave rider configuration, meaning it literally surfs the shockwaves it creates to fly more efficiently. And it comes in 3 distinct designs. You've got the conical body, which offers robust stability for 1,500-kilometer ICBM-class strikes. Then there's the winged body, using delta wings for high maneuverability, which is perfect for 2,000-kilometer naval anti-ship missions. And finally, the blended body. This one is stealth-optimized and built for that massive 10,000-kilometer intercontinental deterrence role. It is an incredibly adaptable platform.
And their development timeline, it is heavily fast-tracked. A full-scale model was just unveiled at the Vigyan Vaibhav exhibition in February 2025, and by December of this very same year, they have a first coastal test scheduled. Moving rapidly from there, user trials with the Strategic Forces Command are slated for 2027, and they are targeting full induction and that 10,000-kilometer range extension by 2029 or 2030. Going from prototype to active arsenal at that pace is honestly astonishing.
Section 4. The Scramjet Breakthrough. India's multi-layered arsenal. This quote from Defense News India highlights a truly defining moment for the program. Back in January 2026, the DRDO achieved a massive milestone. They successfully ran an actively cooled scramjet engine on the ground for more than 12 minutes. Why is that such a big deal? Well, a scramjet requires airspeeds of around 7,000 kilometers per hour just to ignite in the first place. But once it's running, it is unbelievably fuel efficient. Sustaining that combustion for 12 whole minutes, that proves they've unlocked the key to long-distance, powered hypersonic cruise flight, permanently moving past the phase of just short experimental tests.
Let's move on and see how this builds a complete ecosystem. India is integrating this tech into a full, multi-tiered strike network. First, you've got the Dhwani HGV for long-range nuclear deterrence, gliding way up in the upper atmosphere. Second, the LRASM, that's a long-range anti-ship hypersonic missile built using completely homegrown electronics to secure the Indian Ocean over a 1,500-kilometer radius. And third, the ETLDCM. This is a cruise missile exceeding Mach 8 that bridges the gap, completely capable of mid-flight course changes and launching from the air, land, or sea.
Section 5. Redefining Regional Deterrence. A shift in military doctrine. Now, according to defense analysts, these advancements are framed primarily as a direct mechanism for securing India's nuclear triad. The geopolitical environment over there is already highly advanced. You have neighboring China aggressively deploying systems like the Mach 5 capable DF-100 and Pakistan fielding systems like the ROD-2. So Project Dhwani and this new network are viewed by defense sources not necessarily as just matching numbers, but as creating a flexible, homegrown countermeasure to the existing regional systems. So the crucial point is that the overarching military doctrine is fundamentally shifting here. When you have systems that turn unpredictably and fly faster than a plasma sheath, traditional layered defenses, they're rendered almost entirely obsolete. As Defense News India notes, this moves a military posture from simply threatening expected retaliation to the capability of piercing enemy defenses with virtually zero warning time. The sheer speed literally dictates the new rules of engagement. Which leaves us with a fascinating question to ponder. Defense Needy recently posed a poll to their readers, and I want to leave it with you as we wrap up this explainer. Will Dhwani shift the regional power balance? Given that massive 10,000-kilometer range, the maneuverable glide technology, and the scramjet breakthroughs we've unpacked today, it is a question with profound implications for global security in the coming decade. Take a second to think about what this really means for the future of aerospace defense. Thanks so much for joining me to explore the data and science behind this incredible technological leap.